Skipping the GCF is one of the common factoring mistakes that students make. So I want to make sure you're solid on how to find the GCF, factor it out, and actually make the problem so much easier. So let's dig into this. So what does it mean to find the GCF? It's the biggest number that goes into everything in the problem. So I see two terms here in this problem, 1, 2, and they are both divisible by something. They have common factors. So let's break it down, and usually you do this in your head, but I'm going to go ahead and write it out here. So 6 is 2 times 3, right? And 15 is 3 times 5. So does that have a common factor of some sort? Sure, they're both divisible by 3. That's the biggest number that goes into both of them. So we call that the greatest common factor, or GCF for short. So we factor that out and we write it out front. Now I also notice that this one has x times x. Those are factors, so 2 factors of x sitting in there. And then this one has a single factor of x. So how many factors of x do they have in common? They both have 1x. So we can bring that out as part of the greatest common factor, the GCF. Now, inside the parentheses here, we are going to write a binomial. That means 2 terms, 1, 2, separated with a plus sign because it says a plus sign here. We're going to just write what's left behind. So what was left behind when we factored out the 3x? We had a 2 here, we had an x here, so those guys go back together again to become a 2x, and then we had a 5 over here that was not part of the greatest common factor. So after factoring the greatest common factor out, I have 2x plus 5 left. You can always do the distributive property real quickly, and I imagine you're really good at that. Just do the distributive property and you should get the original problem right back. And you do here. So that's a real basic problem on factoring out the GCF. I've got 2 more examples, and the last one does have a bit of a twist to it, so stick around for all 3 examples. So here we have what's called a trinomial. So now you have to juggle, what goes into 8, 12, and 20. All 3 things. What's the biggest thing that goes into all of them? I bet you can come up with it. They're all divisible by 4. So we're going to pull a 4 out of all of them. Now, what about the x's? Do they all have x's? Do they all have at least 1 factor of x? Yes, they do. This one has 1, this has 2, and this has 3. So how many do they have in common then? They have at most 1 in common. So 4x is the greatest common factor. Now I'm going to open up a parenthesis. I like to just go ahead and put my minus and my plus there, so I have my 3 spots ready to go for whatever's left behind. So what do we get when we take 8x to the third and we divide it by 4x? What do we get? What's left behind? So wouldn't it be 2x squared? Now, if you do your distributive property and think about multiplying those 2 things, you'll get your 8x to the third right back. All right, moving on to the next term. What do we get for this 12x squared? What would have to go right here? It would have to be 3 because 12 divided by 4. And then we have 1x left behind. And then finally, at the very end, we have the number 5 because 4x times positive 5 would give us our 20x. So you have to have that plus 5 there. Now in future videos, we're going to look further and just check to see if maybe this could factor further. But in this video, I'm trying to keep it simple, and we're just keeping it to the greatest common factor. All right, I've got one more example. You ready? Wait for it here. What do we have here? Oh my goodness, we've got 2 different variables floating around. That's okay. We can still break it down just like we did that first problem where we think about how many they have in common. All right, just looking at the numbers first, 3 and 12. What goes into both of them? They're both divisible by 3, so that's part of the greatest common factor, or the GCF. What about x's? Do they both have some x's in common? Sure. How many x's? This one has 2, x times x. This has 4, so how many do they have in common? They have at most x squared in common. Now what about the y's? This has y to the first here, and this has 2 y's here. So how many do they have in common? By they, I mean these 2 terms that are being added. They have 1 factor of y in common, so y to the first. Now we have to write what's left behind. So what would have to go right here in this first blank to give us this first one right here? Well, we took 3 and we divided it out, so there's an invisible 1 that's going to go there. If we have 4 x's, or x to the 4th, 4 factors of x, and we divide 2 factors out, 4 take away 2, 4 minus 2 means we have x squared left over. And then the y that was here has been moved outside the parenthesis, so it's no longer there. And then let's look at the second term. 12 divided by 3 is 4. We had an x squared, and they both came out, so that's done. And then we had 2 factors of y, and one of them came out, but look at that. We still have 1 left behind. So we would have that right there. Now again, you could do your distributive property and make sure you get the original problem back. But this is what your teacher means, or what I mean by factoring out the GCF. Always look to do that first, because it really does make the number smaller, these numbers right here, so that later in the chapter you'll be able to do more and more factoring. All right, if you think you have the hang of factoring out the GCF, check out this next video on how to start factoring trinomials where the leading coefficient is 1. All right, good luck.